We're going to study end behavior. Now, end behavior, hey, listen, you guys. End behavior is really what? Studying what this thing looks like as it approaches positive and negative infinity. That's what end behavior really is talking about. Now, here we have a different example. Here we have our leading coefficients for both the numerator and the denominator are really what determines what the end behavior looks like, because the rest of the stuff is kind of insignificant, right? They kind of cancel each other out. When you blow up towards infinity or go in the other direction towards negative infinity. And so normally when you want to study the end behavior of a rational expression like this, you really just focus on the leading coefficient. So let's just pull those out and look at them. The end behavior for this whole thing would be the same as, or similar to, the end behavior of 2x to the 5th over 3x squared. Well, I've got 5 here and 2 on the bottom, so 2 on the bottom will cancel with 2 on the top, and this becomes 2 over 3 x cubed on the top, right? Well, if I approach infinity with this term, what will the limit approach? No.
1.
Nope. 2. Well, it's 2 times infinity cubed over 3. What is that approaching?
You can't have
Infinity. So the limit of this function would approach infinity. Does that make sense?
No.
Now, if I approach negative infinity, I'd put negative infinity here. When you cube a negative number, it becomes negative, right? It doesn't change it. So, in other words, if I were to take the limit of this as x approaches infinity, I'd get positive infinity. If I were to take the limit of this as x approaches negative infinity, oops, I wrote it like an 8. Oh well.
It is an 8.
That should be negative infinity. So I very quickly, simply just applying practical common knowledge, have determined what those are. How could I validate that claim quickly? Graph it. Very good. So I'm just going to plug this in the calculator. Do I have to graph the whole thing? No. No. I could just do the leading coefficients. Now, for due diligence, I'm trying to show you guys quickly, you probably should graph the whole function. You probably should. But Mr. Adams just wants to real quick show you how this stuff works. So if I say 2x raised to the 5th divided by 3x squared, yeah, right? As I approach negative infinity, what does my y value approach? Negative infinity, right? So as I go to the left, which is x and the negative, well, let me write this down on paper so you guys can see it. So this is positive infinity, this is negative infinity, this is the y direction, and I've got like it's a cubic, right? We showed that it was a cubic, right? But as I approach this way, my y value approaches negative infinity in the y direction. So that's that answer. As I approach in the x direction, right, as x approaches infinity, I go this way, but my y value approaches positive infinity. Does that make sense?
Yeah.
Okay, good. That's all you got to do. What if they're the same? What would happen? So let me give you another example. What if I had something like this? What if, this is not in the textbook, so I really want to have you guys write this down, example 7b. What if I had f of x and it was 2x cubed all over 5x cubed What would my end behavior look like there?
It's 2 over 5, right?
Yeah. So my limit of this function as x approaches infinity or negative infinity, it would be
2.
these cancel out and I would get 2 over 5. Now here's what's not in the book. If I take g of x and I have 2 x squared over 5x cubed, what does this limit look like?
2 over 5x.
Yeah.
It's so weird to hear the Sharpie, but it doesn't teach up fast enough.
Yeah.
Good to see where your mind's at there on there. What's the answer to this?
0.
0, right?
So if infinity's on the top, then it's approaching infinity, but if it's on the bottom, it's approaching 0.
Oh, I loved it. She came up with some rules. All right, so when we're doing rational expressions
That was a question, don't.
and
No.
behaviors
No.
for rational expressions, why did I call it rational expressions?
Because the numbers go on?
Because it has the word ratio, and ratio is really what? A fraction. If how would I write this? The numerator has a higher degree, and I'll write this kind of informally. What do we know? If the numerator has a higher degree, what was my limit as f of x approached infinity? If the denominator has a higher degree,
You put the wrong then. There you go.
no, I had the right then.
No.
No.
It's E.
Has a higher degree.
I had E, and she said I should have put A.
Yeah.
Yeah, you're not comparing them.
Yeah, if then.
The numerator has a higher degree.
If then, it's a syllogism. If this occurs, then.
It should come up after degree.
No, there shouldn't.
Math, not English.
Are you
You knew
higher degree than the denominator?
No, as we were learning calculus, it's not. It
No.
really doesn't matter.
You do not, shh, in formal language, you do not have to write a comma here. You can,
I don't care.
Is that A?
but you do not have to, right?
It doesn't matter.
And then THAN is referring to like a quantitative term. You're comparing, saying one thing is more than another.
I know, I'm saying it's the first one. If the numerator has a higher degree than the denominator.
No, that's not what he's saying. Well, yes. Yes.
Well, yeah,
That's not the
but that's not what I was
But
saying.
is that what you mean by that sentence?
Yes.
Then I
No.
need to write it that way.
Well, then write it however you want.
Sentence, but that's not what he's saying.
Okay.
Okay,
But
so
then it's just what?
God.
but if there's only a numerator and a denominator, and I say the numerator has a higher degree, then we can assume it's implied that it's higher than the denominator.
Okay, well, I'm writing it out.
Okay, good. Whatever helps you. If the denominator has a higher degree, what would we do? What's the limit look like? 0. And then if the numerator and denominator have the same degree, So if the numerator and the denominator have the same degree polynomials, then it's just the ratio of the leading coefficients. Because these terms cancel. And any term after that is insignificant. Well, as you approach infinity, it's not insignificant in general, but when you approach infinity, it bears little impact.
Wait, what's LC?
Leading coefficient. LC is leading coefficient.